Hello, everyone. Today we're going to be going over the 75s, which is a lab that we did on Thursday. So if you're a 100% virtual student, you're going to notice that all of your numbers will match up absolutely perfectly. If you are a student that actually did the lab, your numbers are going to be a little bit different. So in this lab, we took a compound that had water locked up inside of it. We used one of our burners. We heated it up. We basically drove off that water, and our goal is to find the percent water that is in the compound. Then we would take that percent water in that compound, go to the 25s where we did all the math, match up the percents, and that would tell us how many water molecules are actually in the compound. So again, for those that were 100% virtual, here are the numbers that you go along. Everyone else, your numbers are going to be close, but they're not going to be exactly what they are right here. So the mass of the empty beaker that I used was 102.56 grams. If you did the actual lab, you absolutely cannot expect that your mass of your beaker is that. It'd be very rare if it actually was. And then I added some compound. It said add about 2 grams of compound. So I added 104.26. That would be the mass of my beaker and the compound that I'm trying to drive the water off of. Grams, and then I do the math on that. So I have the mass of the beaker with the compound in it. I subtract the mass of just the empty beaker. And following the addition and subtraction rules for multiplication, I end up getting an answer of 1.70 grams. On your calculator, that 0 probably does not show up, but make sure you follow the sig fig rules. This one goes to the hundreds place. This one goes to the hundreds place. So I better have a number that goes to the hundreds place. And so I ended up putting in 1.70 grams of hydrated compound. Again, if you did the actual lab, your numbers will not be like this. They will be similar. This number will be around 2, somewhere in that ballpark. So then what we did is we took this beaker with the hydrated compound in it. We placed it on a ring stand. We put a burner below it. We heated it. We cooled it. We masked it. So the first time I did it, I got 103.49 grams. That is the beaker, and that is the compound that we're trying to get rid of the moisture. So when we get rid of the water, it will eventually be anhydrous. I did it again several more times, and I got 103.42. And I did it again, and I got 103.42, and I did it again, I got 103.42. And when the water mass doesn't change anymore, we are making the assumption that we have driven off all the water that was available. So now we have to do the math for this lab. Now this math is going to show up on quizzes or a test. It's going to show up on your next review sheet, which will be probably the day after today. So you need to be able to do this math yourself. If you have not done this math, you should definitely give this a try. Stress your brain out a little bit. That's how you learn. But in my problem, number 8, it says subtract the mass of the beaker. Well, my mass of my beaker is 102.56 grams. And the mass, subtract the beaker to get the mass of the anhydrous mass. So the anhydrous compound with the beaker, that mass for me is 103.42. I do that math. Both my numbers go to the hundreds place, so I better have an answer that goes to the hundreds place. And I do, and I get 0.86 grams of anhydrous material. So that is my dry material, no water is locked up in it. The beaker is not there. What is the mass of water in the hydrated compound? Well, I know the mass of the hydrated compound in the beaker. So this is the beaker plus the hydrated compound. And for me, that would be 104.26. I got that from the very top. That was number 3 at the very top. And then I'm going to subtract out the mass of the beaker with the anhydrous compound. So this is the beaker plus the anhydrous. Anhydrous again means we've driven off all the water. And in this one, it was 103.42. And that I got from number 6. I do the math on that, and I get 0.84 grams of water that was driven off. So the mass of the water that I drove off was 0.84 grams, and up here this was 0.86. Again, anybody that actually did this lab, your numbers are going to be slightly different. Now I need to calculate the percent water. So anytime I need to calculate the percent of anything, it's the part that we want to know about divided by the total thing. So we want to know the percent water, so the grams of water go on top. So 0.84 goes on top. What's the whole thing? Well, it's the compound plus the water. Compound plus the water. And do I have that? And yes, I do up in number 4. It's the mass of the hydrated compound. So this would be 1.70. That is the whole thing. That is the compound with the water locked up in it. And again, that was number 4 from above. So this is the water. This is the hydrated compound. Now I multiply the whole thing by 100, and I end up getting 49.4117. Now with sig figs, I got 2 sig figs there. I have 3 sig figs there. So my answer should have 2 sig figs. So my percent water is 49%. Again, if you did this lab yourself, your numbers are going to be slightly different. I will tell all of you when I say everything, this bottom number, I don't include the beaker. Nothing changed with the beaker. We're not looking for any information about the beaker. So that's why it's just the hydrated compound. So now what I need to do is I need to go to page 25.1 and I need to look for 49%. So if you did this page correctly, this is all for magnesium sulfate. So all for magnesium sulfate, I'm looking for 49%. And 49% falls between these two. Now, this is the time that you have to look into your own ideas about how the lab went. If I chose to go with the 47%, that says I drove off, since I got 49%, and this says 47, it means I drove off more than just the water. So was there anything in the experiment that happened that would make you say I lost more than the 47% water that is in there? If that is the case, then you would say you have 6 H2Os. If you feel that somehow maybe you just didn't drive off all the water, and again, our number is 49% right between those two. If you think it's more likely you just didn't drive off all the water, then you would go with the 51.145%, and you would say 7 H2Os. Either way, our answer is going to be 6 H2Os attached to it or 7 H2Os attached to it. And the actual answer is 7 H2Os. And you should not feel bad if you chose 8 H2Os or if you chose 6 H2Os if you did the lab yourself. Errors are inherent in labs, and this is one of the first chemistry labs that you had to do. All right, so now we're going to go to the back side, and if you did not answer the back side, you should absolutely be pausing the video right now and trying to figure out the back side, because a lot of work went into creating those, and you're going to get a lot of learning out of trying to figure out these errors. Error analysis occurs in our next lab. We have a very similar lab to this, and if you do the work here, that next lab is going to be a lot easier. So what I'm saying here is the back side of the sheet is all about errors, and all the errors revolve around this. If somehow the mass of water lost is not calculated correctly, and what I mean by that, something happens to the grams to make the grams of water go up or the grams of water go down through an error, that's going to change your percent water in the compound, which is going to make you look at the table and pick a different number of water molecules. So all the errors revolve around grams of water. That's what I'm trying to say. So the errors, when we go over the back side, they're either making the grams of water go up or the grams of water go down. And can you think through the process of what that would do to the number of water molecules in the compound? Again, if you have not done the back side, please pause the video and do the back side before you watch the video. So on the back side, it says the error, you placed a dirty stirring rod into the beaker after it was heating for several minutes. So if the stirring rod is dirty, guess what? You just added material into your beaker. This whole process, what we're doing is we have a beaker with the hydrated compound in it, and then we're going to have a beaker with the anhydrous compound in it, and we take the difference between that and we find out our water. Well, if we're adding a dirty stirring rod, we're adding material into the beaker that's never going to evaporate away. So what's that going to do to the grams of water lost? So if I don't lose as much mass as I'm expecting, then I have less grams of water loss. If I have less grams of water loss, then I'm going to choose a lesser percent. If I choose a lesser percent, then I should be choosing lesser water molecules in the compound, and I would go with a smaller number. So that would add mass to your beaker. If you didn't realize the error that you made, this would make you think that the mass change was due totally to water loss. This error would make it seem like the grams of water lost in number 9 in the previous page were less than they should have been if the error was never made. So again, I have a beaker, I have a compound, we're measuring how many grams are lost, but if I put a material into it, if I somehow put a chunk of something into it and I don't realize it, well, this water is still going to evaporate away, but this is going to stay there and my overall mass is not going to change as much as it should. This error would make you pick a hydrate with a lower number than it should really be. So we said it's a 7 and 7 H2Os, and this error might make you think it's a 5 H2O, all based on the masses. All right, if you place a stirring rod into your beaker and it became coated with the chemical, the hydrated compound, when you place the stirring rod on the table, the chemical from the stirring rod was transferred to the table. Well, this means we're sticking a stirring rod in there, and every time we pull that stirring rod out, it's coated with stuff. And so we're removing extra material from the beaker besides just the water. So this would remove mass from your beaker. If you didn't realize you actually had this error would make it seem like more water was lost than it actually should have been. And this would make you pick a hydrate number higher than it should have been. So again, we said it was 7 H2Os. This might make you pick 8 or 9 H2Os. You massed out your chemical into the beaker. You place the beaker on the ring stand. You start to heat it. You see and smell a paper label that was stuck to the glass beaker burning away. So you have a beaker. Again, we're supposed to have water that's going away. That's what we're measuring. But you have this label that also burns away. Well, we're going to think that label mass was extra water that burned away. So this is going to remove mass from your beaker. It's going to make it seem like more water molecules were actually lost. And that's going to make you pick a higher number than you would expect. You massed out your chemical into the beaker. You place the beaker on the ring stand. You start to heat it. Your burner's working really well, maybe too well. A piece of wire holding up the beaker melts into the beaker and detaches from the wire platform. So again, I have this, and I have some wire underneath it. It actually sticks to it and it holds on. Well, again, we're measuring this mass of water coming off of it, but this piece of wire is actually adding mass to it. So this is going to make it seem like we're adding mass to the beaker, which is going to make you choose a less percent water, which is going to make you choose a number smaller than 7 for your answer. You don't heat your beaker long enough or intense enough, and this is probably the number one error that actually occurs. So if you don't drive off all the water, you don't lose as many grams. So that would add mass to your beaker with the compound in it, meaning, okay, I'm supposed to remove 5 water molecules, but I don't heat it long enough, and I only remove 4. So in other words, I have more mass in my beaker than I would expect if I thought it was all removed. This would make it seem if there was a less percent water. Well, if I only drove off 4 of the water molecules instead of the 5, that would be less percent water, which would make me pick a number that was lower than it should be. A lot of errors. That's where a lot of thinking occurs. Your beaker is heating well, maybe too well. The heat currents rising up on the outside of the beaker are carrying molecules out of your beaker. So again, we're measuring water loss, but this gets so hot, it causes air currents to come through and actually grab some of that dry stuff and pull out some of that dry stuff. Well, we're going to think that's all water. And so that's going to make us seem like we lost more mass than we actually should have. So we removed or have less mass than we would expect. This would make it seem like there's a higher percent water because, again, we are measuring the mass difference between the hydrated compound and the anhydrous compound. And here we're losing more mass than expected, therefore making it seem like there's a higher percent water, which would make us pick a higher number, something higher than 7. And that is everything, folks. So have a good day.